Hello everyone! This video would focus on conic section, specifically on hyperbola with center at 0, 0 or at the point of origin. And this is the second part. In this part, we're given the general equation of a hyperbola and we're supposed to sketch the graph and fill these variables in. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola with center at 0, 0 or at the point of origin. Before we jump into this example, let's have a review on the parts and the two cases of a hyperbola. Please notice that this hyperbola is called a horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co-vertex, and there are two of them. We call them as co-vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola and it passes through the focus, and there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices, and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis, that is from one vertex to the other vertex, is a formula of 2a, while the length of the conjugate axis, that is from one co-vertex to the other co-vertex, is 2b. Now, the equation that relates all these three lengths here, a, b, and c, is c squared equals a squared plus b squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is c over a. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now please notice that our vertex is on the vertical axis. That's the reason why our A is under the Y. Remember, Y means up or down. And that's the reason why the A squared is located under the Y squared. Now, we also remember that our Y squared over A squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. Okay, going back here, since we are given the general equation of a hyperbola, we're supposed to change it to its standard form so it's easier to graph it. So we go ahead and change this to its standard form. The first step that we're going to do is to copy this first. I'm going to go ahead and write that up here. We are going to add 400 to both sides, so the constant will be added to both sides. So this equation would come out. So I'm going to go ahead and cross the 400 out. So this will be 25y squared minus 16x squared equals 400. Now, in the standard form, the right side of the equation should be equal to 1. So this tells us that we're going to divide everything by 400. So I will divide each of them by 400. Now we are going to reduce this to lowest term. This tells us that if we divide 400 by 400, that gives us 1. And to reduce this values that we have here, there's 125 in 25, and there are 1625 in 400. And there's 116 in 16, and there are 2516 in 400. So I go ahead and write this down here. So that would be y squared over 16 minus x squared over 25. This is the standard form of this general equation of the hyperbola that we have up there. From here, we can go ahead and say that this is an example of a vertical hyperbola. The reason for that is since our y squared over 16 is positive, y is the vertical line. So we go ahead and say that this is a vertical hyperbola. So I'm going to go ahead and write that up here. Since this is an example of a vertical hyperbola, the one at the bottom of y squared is our a squared. So I'm going to go ahead and write that up here. A squared is equal to 16. This tells us that our a then is plus minus 4. And this tells us again that our 25 here is the b squared, which is the denominator of x squared. So if we get the square root for both sides, our b is plus minus 5. Looking at this is an example of a hyperbola with center at 0, 0. So I'm going to go ahead and write that up here. Our center is at 0, 0. So I will plot that down here. This is the center of this hyperbola. And since we say that this is a vertical hyperbola, our a is the number that we go up and we go down. So I go up 4. So this is our first vertex. And I go down 4. This is the second vertex. This B will give us the location of the co-vertices. So I go left 5 and then I go right 5. Those are the two co-vertices. So I'm going to go ahead and write the coordinates of the two vertices and the two co-vertices up here. From here, we can determine the length of the transverse axis. Remember, the length of the transverse axis is the length from the vertex to the other vertex. And the length of the conjugate axis is the length from the co-vertex to the other co-vertex. So I'm going to go ahead and show that work up here. So the length of the transverse axis is 2a, and that would be 8. And the length of the conjugate axis is 2b, and that would be 10. Now let's draw the rectangle and the two asymptotes. We remember that this rectangle here will help us draw the hyperbola later on. And this rectangle should cover the two vertices and the two co-vertices. And the diagonal of the rectangle would be the location of the two asymptotes. So I'm going to go ahead and sketch those two asymptotes up here. Okay, the equation for these asymptotes would be, let's start with this one right here. So that would be y equals, again, we always go up and over, or you can use the formula, but in order that you don't have to memorize any of those formulas, we can use the up and over. So that would be going up 1, 2, 3. So from the center, I go up 1, 2, 3, 4. I went up 4 over, I went to the left, 1, 2, 3, 4, 5. So that would be negative 5x. While the other equation would be y equals, I go up from the center, I go up 1, 2, 3, 4. And then that is over 1, 2, 3, 4, 5. And that's a positive 5 because I went to the right. So these are the equations of these two asymptotes. This is the first asymptote with the negative slope. And this is the second asymptote with a positive slope. So we can go ahead and sketch the hyperbola. Our next task is to determine the location of the two foci. In order that we can do that, we're going to use the equation c squared equals a squared plus b squared. So I'm going to go ahead and write that up here. So let's plug the values in. So that would be our a squared is 16 and our b squared is 25. So then we go ahead and solve for c. So our focus is located 6.4 up and 6.4 places down. So this is 5, 6, 6.4 should be somewhere around here. That's the first focus. And the other focus would be 5, 6.4. That should be somewhere down here. So this is our focus. And so the coordinate of the two foci would be... Now let's determine the eccentricity. Now we remember that the formula for eccentricity is E equals C over A. Since our C here is square root of 41, and so our A here is 4, so I go ahead and write 4. This is the eccentricity. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We're given 16x squared minus 9y squared minus 144 equals 0. This is a general form. I'm going to show you the work on how to change this into its equivalent standard form. I'm going to show the work down here. So this is the equivalent standard form of this general form of the hyperbola. Since we have a positive x squared over 9 is the positive part, we can go ahead and say that this is an example of a horizontal hyperbola. I'm going to go ahead and write that up here. Since this is an example of a horizontal hyperbola, under the x squared is our a squared, and under the y squared is our b squared. So I'm going to go ahead and solve for a and b. The center for this hyperbola that we have here is at 0, 0. So I'm going to go ahead and write that up here. This is located, or the center is located at 0, 0. So that we can go ahead and sketch this center here that is at 0, 0. And then we go ahead and, since this is a horizontal hyperbola, I go to the right 3. So this is our first vertex. And then I go to the to the left 3 and to the right 3. So this is the other vertex. And the B will give us an idea on where the co-vertex is located. That would be up 4 and down 4. So this is our first co-vertex, and this is the other co-vertex. So we can go ahead and write the coordinates of these two vertices and these two co-vertices up here. From here, we can go ahead and draw the rectangle and the two asymptotes. The equation for this asymptote with a negative slope would be, that's going to be y equals, I go up and over, 1, 2, 3, 4, over, that's going to be negative 1, 2, 3. That's going to be negative 3x. And this asymptote with a positive slope would be y equals, I go up 4, and then that's over 3x. So these are the equations of these two asymptotes. Now let's determine the length of the transverse axis and the length of the conjugate axis. I'm going to go ahead and show that work up here. Okay, so the length of the transverse axis is 6 and the length of the conjugate axis is 8. Now, let's sketch the hyperbola. Okay, now let's determine the location of the two foci using the equation c squared equals a squared plus b squared. I'm going to go ahead and show that work up here. This tells us that our foci is located 5 spaces to the left and 5 spaces to the right. So this is our first focus that is 5 spaces from the center, and then 5 spaces to the right. This is the other focus. So these are the coordinates of the two foci. Now we remember that eccentricity is E equals C over A. Our C is 5, so I plug that in there. 5 over our A is 3, so our eccentricity is 5/3. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!